Okay, guys, response to the environment by humans. My name is Mr. Mpepu. I personally welcome you to my class. Today's date 19 April 2024 and the time there 12 minutes past 12. With that being said, Sanbonani, Tumelani, Avsheni, hello. Nah, guys, to all corners of South Africa and Africa Kabupar. Today we'll be dealing with disorders of the central nervous system. I welcome you guys. Those who are new here, subscribe, comment, like. Those who are returning students, guys, I really like to appreciate you. I appreciate you guys. Let's do disorders of the central nervous system. Learning left science with Mr. Pip. Thank you and thank you and thank you. Yesterday. Okay, with that being said, guys, I welcome you. I appreciate you. Last time I checked, we were at positive 77 subscribers. So if you haven't subscribed, guys, please do so. Today we'll be dealing with disorders of the. Okay, it's fine. Let's move on, guys. Let's move on. We are today's date 19 April 2024. Friday, right? Today it's Friday, so today marks the end of week 5 here, right? Under responding to the environment by humans, we are done with human nervous system, we are done with central nervous system, we are done with peripheral nervous system divided into autonomic and somatic nervous system. We are done with the nerves and reflex arc, those connectors that they are sending message from the effector to the from the receptor, those that are sending message from the receptor to the central nervous system, from the central nervous system to the effector. We are done with this, right? We know this one they are called what we call this will be the revision. This one they are called sensory neurons, sorry, and this one here they will be called motor neurons. So we are done. We know that we have the receptors here. We are going to do the receptors organs next week 6 and week 7. So stay tuned, guys. Shosho loza, guys. This train might be using the old engine, or maybe the train might be not that much comfortable based on my English and my information that I'm giving you based on the time that we are spending learning this life science, guys. The engine might be old, but as long as the engine or as long as the train is moving forward, guys, forward we go, backwards never. Forward. Let's learn life science with Mr. Mpep. We are done with this one, right? You'll agree with me, grade 12 students. Today we'll be dealing with disorder as per our weekly plan. Monday, Tuesday, Wednesday, Thursday, and Friday, right? With our weekly plan, we did that Monday we are going to learn human nervous system. Tuesday we are going to learn central nervous system. Wednesday we did question and answer. Here we talked about the brain, the structure of a spinal cord, the cerebellum, and then Thursday here, if you missed them, you can still go back tomorrow. I won't post any videos so that those who are left behind, they can still catch up, right? We'll come and do human eye Monday. Today we are done with this week. Done. We'll be done. At the end of today's lesson, you should be able to explain, man, to give a brief explanation of what will happen if something happens to this nerve system, right? The one that is transmitting the impulse from the receptor to the central nervous system. What will happen if we cut here? Those are the disorders, right? Disorders are something that they are happening and we cannot sort of like it's happening at a larger quantity. We have a scenario where we said, what will happen if we cut a sensory neuron here? What will happen if we cut the motor neuron here? We were building your understanding so that when we come to the disorder, you'll understand that if we have the disorder that is destroying these cells here, it means that we'll have a results here that maybe the person won't be able to feel the pain and won't be able to respond to the pain, right? So these are the disorders. We have the one that is killing, or that is due to degeneration or removing of this, or we can say these cells dying, right? The first one. And the second one, it's what will happen if because we have myelinated sheath here, we have myelin sheath, and this myelin sheath, we told you that this one, it impulse or it speed up the reaction, right? It speed up the reaction, it speed up the impulse, right? Speeding up the impulse resulting in a speeding up of reaction, right? So we know, or we asked you, what will happen if this neuron here, which will be motor neuron in my small diagram here, what will happen if this neuron here is not myelinated? Well, now you will have to understand that if it's not myelinated, the speed of the impulse will be shortened or will be slow. Right, so with you knowing that, now we can come to disorders. Or what will happen if we see that the large number of our our nerve cells or our neurons, they are being destroyed on a myelin sheath, right? So now you'll know we have two. We are going to concentrate only two, which will be the Alzheimer and the multiple sclerosis. At the end of the day, you should be able to name those two, a reference to those two, or even diagnose someone, come across someone suffering from whatever. We are saying this will be our first disorder or our second disorder. You can say, this person here, he or she, this person is suffering from Alzheimer or is suffering from, say, multiple sclerosis. With that being said, guys, sanibonani, dumelani, avsheni, hello, welcome to my class, guys. Welcome to my class. We are pushing on. We are fun with this week. You'll agree with me. We did human nervous system, we did the brain, they have cerebellum controlling all voluntary movement, and we also have cerebellum coordinating those voluntary movements. We have medulla oblongata, breathing, peristalsis, all those, and then we also have what we call another one. We have corpus callosum, which was connecting the left and the right hemisphere. We also talked about the spinal cord. You remember this, right? I'm just jogging your mind, or I'm just picking up your mind so that you can pick those memories and place them together so that we can use them in this lesson of ours, right? We also did the spinal cord. We said the spinal cord, it complete a reflex arc when we were talking about the reflex arc or reflex action, right? And then from there we talked about the nerves. So these nerves here, the connector, we have the sensory neuron, and we also have the motor neuron, right? We also talked about the interneuron inside the central nervous system. From there we talked about the peripheral nervous system, saying that we have this peripheral system is made out of a receptor, the sensory neuron, and the effector, and the motor neuron, right? So we have the autonomic nervous system, that this autonomic nervous system, it's going to affect, or the impulse is going to be sent to a same organ. And then this autonomic nervous system is divided into two parts, sympathetic and parasympathetic. With sympathetic, you will agree with me that we said this one, we can say it is increasing, and then parasympathetic, it is decreasing. They work antagonistically. For an example, sympathetic, this will be the motor neuron sending an impulse to the heart, and then this will increase the heart rate. And then the parasympathetic will be also the motor neuron sent to the heart, and then decreasing that heart rate. I'm not sure if that information was enough for our today's lesson. So let's go and learn our today's lesson. We pass by the caps. These are the three streets, right? We pass by the caps, and then in our caps we can see that the disease were included there, the injuries, and then the effect of drugs. Even though they don't ask you about this, these are not examined, right? So when now you'll know that, or you'll understand with disorders and injuries, you can now explain what is happening when you have drugs, right? And then what will happen if maybe you are injured, maybe like for an example, car accident, and then you end up, by this time you should be able to explain this without me telling you what are we going to talk about when we say someone is injured, or someone central nervous system is injured, right? You know, when we disturb central nervous system, that person can be paralyzed, because where are you going to receive the messages to your arms so that you can stand still, right? You can move. Those coordination, it means that your cerebellum is disturbed, you cannot breathe. It means that your medulla oblongata, it is disturbed. And then with disorder here, you can see that we are only going to concentrate on the one named Alzheimer's and the one made multiple sclerosis, right? So this will be our caps, or this is what you are that you need to know, right? From there, this will be our Friday. We talked about this, that Friday. Today we're going to talk about disorders that are affecting central nervous system, right? But they say we have to know the causes of this. What is it that is causing this, or how are these caused, right? For us to end up saying this person unale Alzheimer, what is happening into this person brains, or into this person nervous system, by us to end up saying this person, we think this person, he or she is suffering from multiple sclerosis. What is it that is happening, right? But the causes and the symptoms, right? What is it that is happening after that? The symptoms, they're just saying, what can we see, Right, for an example, is these are you know that this one are related to a central nervous system. Let's say for an example, you are losing memory, right? You are losing memory, and we know that our cerebrum or our memory is controlled here in our cerebrum, right? So you are losing a memory. When you are losing that memory, we can now come and say, because the person is losing memory, he's showing the symptoms. Those are the things that you are showing, right? And then those symptoms, we know if this person is losing the memory, we can now think, or maybe the person is suffering from Alzheimer out of that syndrome, out of that symptoms, right? Same as symptoms to HIV. You start to lose weight. You understand, while you are losing weight, your skin is tomoba. You understand, your skin start to be something different. That's when we can say, oh, maybe the person, he or she, is suffering from HIV. That is the symptoms, right? We have the symptoms, we have the effect, we have the all those words, right, that they use. Symptoms, they also use them on our daily basis. Hey, someone is suffering, or someone is showing the symptoms of HIV. Someone is showing the symptoms of TB. Maybe like your temperature is increasing. Those are the symptoms, right? So today you learn what is causing this Alzheimer if we're talking about the Alzheimer, what is causing this multiple sclerosis if we're talking about multiple sclerosis, and what are the symptoms. What is it that we are going to see and say and conclude that the person might be suffering from multiple sclerosis by following disorders of nervous system, right? So in our a study guide, in our examination guideline, this is our examination guideline. You can see that the part here is only two parts here, but when now you'll have to understand this so that you'll be able to answer questions. Mind you, this section here in paper 1, it brings it houses 54 marks. We find it up there, and then out of these 54 marks, I found a question paper last year holding 40 marks under this topic and disorder of CNS, right? So when now you have to develop this background of Alzheimer, what is it that is causing Alzheimer, right? So these are the two if I can give me maybe like if I can ask 2 minutes or 2 seconds of you to introduce these two diseases, right? In Alzheimer, we are going to say we have our effector here, and then effector here it's going to send our receptor they are going to send the message via the sensory nerve neuron via the dorsal root, right, via the dorsal root, and then to the central nervous system, right? This can be our spinal cord or our brain, right? From central nervous system, we're going to see another interneuron passing and then we're going to see another neuron. Here will be our body, this will be our dendrites, our synapses, right? Then from there we'll see an interneuron or the axon of interneuron leaving the central nervous system, going and affect a muscle or an organ called an effector. This time you know this, and you should be able to explain this to someone, right? You are explaining central nervous system. So here's the thing. When we say someone unali Alzheimer, or this, when we find disorders or these disorders that we are going to learn under this chapter, the first disorder we can say this is when these neurons of ours, they are dying. Or when these are the nerve cells. You know, these are the nerve cells, and we told you, or when we did an introduction to nervous system, we said our brains and our spinal cord are made out of a nerve tissues that they cannot repair themselves, right? So it means that when these cells are dying, the cells are going to die. To understand, let's say maybe your sensory nervous system, your motor neuron, your interneuron, they are dying, right? While they are dying, because now you can understand when these cells say they are dying, it means that the person won't be able to send more impulses to the central nervous system. If the interneuron, they are dying, it means that the sensory and the what will send the message to the central nervous system, but the person is not going to what we call another thing. How can I put this? Maybe the person won't be able to store the memories on what, right? So this will be the Alzheimer. And then with multiple Alzheimer, they are dying, right? Or we are removing them, right? Alzheimer, we are removing them. Multiple sclerosis, because we know that we have a myelinated sheath that here increasing or insulating our axon, increasing the impulse. Now in multiple sclerosis just means multiple scars, right? Sclerosis, those are scars. So where are we finding these scars? We are finding them here in our myelinated sheath. It means that in this disorder here, or in these diseases, our myelinated sheath, the neurons are there, or the nerve cells are there, but the problem here is that our myelinated sheath, they are being destroyed by what? By our body. This process called autoimmune, right? Our body is fighting against our body. It means that somewhere, somehow we are producing things or cells that are coming and chow down these myelinated things. So what are these going? What will be the causes of this? What will be the results of this multiple sclerosis? The results of this multiple sclerosis is that now the impulse will be slowed down. You will feel the pain. Here's the thing: you will feel the pain. You will react from the stimuli, but your reaction and your feeling of the pain will be delayed. Right? Get it? These are the only two diseases that we are going to concentrate, or we are concentrating here at grade 12. Alzheimer, the cells are dying. Multiple sclerosis, we are having the scars at our myelinated sheath. I hope you understand that, right? So this myelinated sheath, and then the symptoms here, here now when we say the symptoms when we found you here, right? Being able to hold a hot pen, and then after holding a hot pen, and then we have a long time of you responding. You are responding from this stimuli after a long time. To understand, compared to someone we deemed to be normal, there's no one who's normal. We just deem, or they are just playing around the circle of being normal. No one is normal, right? So when we compare you to someone who we deem, or someone we can say this person can be a normal person, their person is going to react there in a faster rate. But you, because you are myelinated sheath, they are being destroyed, you are going to take time to respond. While you are taking time to respond, we can say that one is the symptoms of multiple sclerosis, right? So what will happen if when you hold there and nothing happen? While you are holding that hot pen and nothing is happening, we ask you, are you feeling pain? No. Hey man, what is happening? Are you not going to pull out? You just see, when I can just see your hand being cooked. If maybe you throw, or you entered your hand, or you placed your hand inside the boiling water, you'll just see your hand boiling and becoming whatever, tender and what. You will see it, but you are not going to respond, because the cells, now we can say those symptoms, or whatever the guy is showing the symptoms, or is showing a possible of that person having Alzheimer. Call it Alzheimer. Alzheimer disease, right? So when you have this background, now you can go and answer each and every question that they can bring you under Alzheimer and under multiple sclerosis. With that being said, guys, welcome. I hope you understand now, right? You understand we only have two: Alzheimer and multiple sclerosis. In Alzheimer diseases, your cells are dying, or they are degenerating, right? You started developing them at your early age. They were going up from 1 to 1 million. I told you that we have 86 billion nerves, or billion neurons inside our brain. Our bodies are made out of 7 trillion nerve or neuron, if I'm not mistaken, but 7 trillion. So when we say they are degenerating, when maybe 1,000 they are dying, you can see, Uri, even though they are dying, they will be still there, right? I'll show you. Let's move on, and then we can go to via our green book, via this street here outside green book. With our green book, we are done, right? They didn't include the disorder. Maybe they include them at the end of these chapters. But when we are moving like this, we see that from here we are moving to a human eye, which will be covered next week. We are done with this one. So here's the thing. Here's the multiple sclerosis and what, right? Here's the multiple sclerosis and what. You can see here we have the health. I can't use the white color. Okay. Here you can see that we have the healthy brain, right? This is our healthy brain. This will be our white matter. I told you, inside it's a white matter, and then the outside here will be our gray matter. As like you can see it, right? This will be our healthy brain. When, because your cells are deteriorating, your cells are decreasing, or your cells are degeneration. Is it the spelling of degeneration? Generation, it means that every day they are being produced in a forward manner. Today we produce 1, tomorrow we produce 2, and then all in all is 3. The following day we produce 3, so forth and so forth. But now they are degenerating, they are decreasing daily by daily. You can see here your brain start to be small, right? Your brain is starting to be small because those cells, they are dying, right? And then you can also see this on our spinal cord, right? With our spinal cord, it means that our spinal cord is going to be shoshabana like this, right? It means that the person, we can measure the brain, we can measure the spinal cord, and we can conclude that the person is suffering from Alzheimer, right? Or we can say this person might be suffering from Alzheimer because this is what is happening, right? And then we can see another diagram on this right hand side here. I managed to come with another one. You can see this one will be our healthy brain, made out of our healthy neuron, right? But a normal neuron, this will be our normal neuron, and then our neuron saving, this one will be a motor neuron, right? This will be a motor neuron, because we can see that the cell body there, it's surrounded by our dendrites, and then we have the axon, and then we have the what we call another one, we have our axon terminals, or our what we call a synaptic knobs. You can see synaptic knobs there, right? So thank you. This is what is happening on our healthy side. And then someone who's suffering from multiple sclerosis, you can see we have a hole there. You can see that these cells, they are dying, right? What you can see now, very amyloid plaque. We have two things that causes this Alzheimer, right? We can caused by this Alzheimer can caused by a dying of our nerve system, right? Or you find that there is a protein, that this protein, they are building around our nervous system, right? When this protein, they are building around nervous system, it means that they are going to squish, or they are going to disturb the movement of impulses, right? So here they gave you the name of those protein. They called amyloid plaque, right? These are we can just remember them as the protein. I'm using a purple color, protein plaque, right? Or protein clumps, right? Those protein, however you want to put this, but these are the proteins that are building around the neurons, right? So with that, we can now also say our brain are being damaged, right? Or the movement of impulse is being compromised, right? So from there, I also gave you another picture down there. This one is multiple sclerosis. You can see here we have a normal nerve, right? This normal nerve is myelinated sheath, and then we have the nerve fiber inside here, which will be an axon or whatever, right? So so you can see with multiple sclerosis, multiple scars. You can see that our myelinated sheath here is being damaged, right? We are damaging our myelinated sheath here, right? As you can see that this is being damaged here, it means that our impulse won't be transferred in a higher speed, right? But the message maybe can reach, because you can see that maybe this this axon will still here. It means when it comes here, it's going to move at a slower rate, smaller rate. When it reaches the part that is normal, and then we go fast, right, up until the impulse reaches your brain, right? So with that being said, guys, welcome to my class. After this class, we're also okay. Another thing that I can leave you after in this picture, I see that we have this our brain of ours. You can see that we have the grooves here, and we also have this top part here. Our brain has the you understand? Here you can see another one. You can see another one. The brain is entering and removing. So these deep grooves here, this groove. When we say the groove, we're talking about this deep here, right? They have a specific name, and they are called sulci, right? Sulci. And the raised area, this area here that is raised here, they also have another name called gyri, or Gary, and then sulci. Right, sulci. But I'm not sure if they will ask you about that. I'm just giving you this information so that you'll see. Maybe someone will ask you why the brain is also is inside out, like is doing a bumps, right? How can you explain those bumps? The groove side, it's called sulci. The top side here, it's called gali, right? Then our gray matter is folding inside, outside, folding inside, and then also our white matter here. So we move on, right? We go to our textbook. We are done with this one. You'll agree with me that we are done. Then today, as we agreed, we are going to do disorders and disorders. So let's do disorders. Those are two. Know those. And then here, let's come to our notes and those what important what we call important information that we can take out, now placing everything in a mannered way, right? But there are many disorders and injuries, right, which can affect the nervous system. There are many things. You can agree with me. You can have an accident, you can have a drugs, you can have what, right? But the use of drugs is the thing. The use of drugs can temporarily or permanently affect the function of nervous system, right? Hence more atoba the drugs, the problem. The person, those nyaupes, boso, Now you understand what is happening. Now from there, now today you'll understand what is happening when you find a new person. When you say, hello, mang, and then the person said, boss, so. Right? So, but how much the nervous system will be affected depends on many things, right? How much the nervous system will be affected, right? So, if you're talking about the accident and then you have your spinal cord there damaged, it means that everything going down is going to be paralyzed. That person cannot work. Hence, we now introduce a wheelchair to that person, right? Because when we damage here, or the damage can be slower. When we say how much the nervous system will be affected, the damage can be coming slower, like multiple sclerosis or Alzheimer. You will see that the person now will be finding it hard to walk, right? Something like that. Maybe they will now use crunchies, they will now use whatever they are using, right? So let's go to Alzheimer there. Then by Alzheimer, this is the disease, Alzheimer. Alzheimer disease is a neurodegenerative. This is the neurodegenerative diseases. Our neurons here, they are degenerating, they are decreasing, right? Which means there is a progressive brain death, a brain cell death, right? Our brain cells are dying. That occurs over time. So here's the thing, it means that you were born, while you were born, growing up. When you are now older there, you might see that your brains were dying. By the time you are a certain age, you have small brains now. Hence, you will see this. But the disease is irreversible, right? The disease is irreversible. You cannot cure it. It's non-curable. When your cells are dead, they're dead. Maybe we can use stem cells. We did a stem cell research. Maybe we can take stem cell, inject them into your brain, and then they will differentiate it to become your nerve tissue, right? Or maybe we can do a cloning. The cloning part, you know that with cloning, we are using your brain tissue to plant some brain cells, and then after having a nervous tissue here, we can cut the tissue and replace your brain. Maybe. But the disease is irreversible, right? And then it is not yet known what causes the diseases. We don't know. We don't yet, but it's not yet known. We don't know why you find that some people, they have small brains when they grow up, right? We yet don't know. But in most cases, the first symptoms appear after the age of 60, but it has been seen in the people as young as 40, right? So as young as 40 there, you can see it, we can see that people from 40 years, they start to think, you can see their brain, they are deteriorating, their brain cell, they are becoming small. But when we get to Wumkulu here, 60 years of age, you know, someone at this age thinks like a baby. That one we can know. We tell that person something today, tomorrow, libates. The person tomorrow has forgotten. So this is what they are saying. With this deteriorating or this shortening or this coming together of our brain, we see it at 60. Right? The symptoms we start to see the symptoms at 60. What are the symptoms? Memory loss, confusion, right? These are the symptoms that we can get here, right? You only have to know too, there are many symptoms that you can think of. This is no cure. There is no known cure that. But the symptoms can be managed, right? We can manage the symptoms. How do we manage the symptoms? Whatever, maybe like we can say someone with multiple sclerosis, let's have a good healthy lifestyle, right? Don't do things that they are going to deteriorate or they are going to kill your brain cells, right? Those drugs that people smokes, those herbalists that we smoke, those high alcohol that we smoke, somehow they are affecting our brain cells and they are killing them. They are killing those brain cells, and then tomorrow at the age of 50 or at the age of 60, we start to show symptoms of Alzheimer. Right? But the symptoms, memory loss and confusion, you can see that when our brain is moving down, we can now talk about many symptoms that our womkulu, our grandparents comes with, right? You can say someone womkulu, they forgot under memory loss because they are going to forget the people that they know. You go to all those who are living with old people at home. As Africans, we live with them home, right? We don't take them to the but what do they call them? The foster the old age house, right? We live with them home. You know that the old person, they will be suffering from recognizing you. Every day you go to that person and you also have to introduce yourself. I'm the mangmang. Nimkuzukulu wako. Indoda mangmang. You understand? This is the thing that their Alzheimer's or their brains now, they are becoming small, right? So we don't know what is causing this and we don't have a cure for this. right? They start to behave like bana, they get confused, they don't record, they think slow now, right? You slower their thinking, their behavior. You come with late, you know this one is just an application to our daily basis. If you don't know an old person, just go to a baby and see whatever the baby is doing. You play something here, there's a difficulty in swallowing, there's difficulty in walking. The older person, they no longer walk properly, they can't walk, but go, they have to hold the sticks, right? It's because their memories are being lost, right? Memories, that when we have memories are being stored there. Then after a long time, those memories, they are going to be deleted, or those cells, those interneurons that are having those memories, they are going to die, and then we are no longer going to remember those things, right? The confusion, these are the only two, or these are the simplest, or we can put them in a simplest form, but you can go out and learn different line, right? The person has a confusion of where they are, what is happening. Maybe like you'll find the grandperson at Kamnyako, go to the gate, and then you go and ask her, what are you doing there? Hasati. Maybe what time is it? Or are we on Tuesday? Do you understand? They are losing their memories and they are getting confused. I hope you understand what is happening in this one. They will ask you, name the symptoms of Alzheimer, memory loss, confusion. You are done. Or if you forgot this, come up with any symptoms that you can say. Or if I can see my older person, or if I can see mom cool at home losing memory, starting to be confused, I can sit down and mama, let's come to pilo. Do you understand? Don't let's pilo, whatever the English to this person. She is suffering, or he is suffering from a disease called Alzheimer. Mr. Mpepu taught us about this disease, right? So we have another one, multiple sclerosis. We have talked about this, or what is happening in multiple sclerosis. But multiple sclerosis is a disease that affect young adults now between the age of 20 and 40 years, right? This thing, because we don't know what is happening. And then the body's, here's the thing, the body's immune system attacks the myelin sheath covering these are, that these are covering the neuron, right? Prevents them from functioning properly, right? We might be talking about the drugs that we are taking, the herbally, the alcohol, everything, the foods that we are eating. You will find that this food, they are causing our body to produce some masocha meal. That our body have the body soldiers, right? Then our body soldiers, you learn this, and the name of this body soldiers, CD4, white blood cells, those, right? So those maybe you take another, maybe you took a savanna, let's take it for example, took savanna, and then your body is fighting against that savanna, it producing masola meal. And this masola meal, because tomorrow the savanna is not there and they are done fighting with savanna, they start now go and attack our what do we call our neurons, right? They go and attack our neurons and now start to feed on our myelin sheath. This is going to affect us. What do we do? We hit you or we burn you. Like, you understand, maybe we burn you with something that is hot, or we light a gun light and we are burning you. When after 5 minutes, or when after 10 minutes, that's when you are going to say, hey man, I'm burning. We know that this one, you are suffering from multiple sclerosis. Where now you are kangani. So, but the reason why this happened is unknown. You see, I was also articulating something that maybe you drink savanna and what, but what is actually happening there, we don't know. This with neurons, or neurons of ours, this is very complicated. Something is happening and we are not sure, or we don't know what is causing that things. Our neurons are being degenerated, but we don't even know what. Maybe they can be an X-ray, maybe they can, you understand, those mutations that we talked about. Remember, we talked about mutations, or these are the genetic to understand genetic disorders that are being passed from generation to generation. Maybe like where now you find that you don't do those things that we are talking about. You don't smoke weed, we don't smoke a cigarette, you don't drink, you don't party, you don't use medication, you don't use anything, but you find that your reaction time is decreasing, right? You might think, well, maybe it's a genetical disorder, right? There's a possibility of that for you to pass that to your offsprings, right? At the age of 20, at the age of 50 there. But also, there is no cure for these diseases. We haven't found a way to come and patch this myelinated sheath. We don't even know how they are produced. So we don't know if you have affected myelinated sheath. Your myelinated sheath, they are affected, you are going to die like that, my brother or my sister. So we don't know how to come and cure this. You can see now there is no known cure, right? We can also do the stem cells, but the symptoms can be managed by a medication or also by a healthy lifestyle, right? We can manage these symptoms, right? So that our symptoms don't be too much, right? We can live a healthy lifestyle, eat those fruit that eat those fruits that they are going to produce us, or that are going to make our cells to develop better. You know, the vitamins, you did vitamins in grade 10. So yeah, but we don't know the cure for these diseases. We don't know, guys. When you suffer that, you suffer that. Then we can give you medication, yeah, and so that we can increase the impulse, so that you understand the stem cell. Yeah, we can also talk about the stem cell and the cloning. We can take the stem cell and inject them where we feel like, or maybe your hand there. Maybe we give. Okay, here's the thing. We take you. We place your hand onto a top hot thing, and then we ask you the question, or we leave you like that. We want to see you reacting or removing your hand out of this hot surface, right? The time that you're going to remove, we take it down, right? 10 minutes, right? 10 minutes there. And then here's the thing. Then from there, when you are not removing that hand, we ask you the question, Mr. Mulatudi, Mr. Mangmang, are you feeling the pain? If you are saying, yes, I'm feeling the pain, but I cannot remove my hand, we can now think, oh, maybe the motor neurons, they are being affected, right? Or if you said, I'm not feeling the pain, or maybe you can remove this hand. Yes, the hot surface, we place your hand and then you remove it fast. But here's the thing, when you are not feeling the pain, but you remove the hand, you can see that your hand is bent there. There's a residue, or there's a left overs of the burning, right? But when you are not feeling the pain, now we can conclude maybe the interneurons that they are receiving this stimulus, sending them to the brain, they are damaged, right? Later, maybe during the night, hence we say during the night, that's where you're going to feel the pain, right? You know when you are maybe or have you broken your hand? Go and ask those who have broken their hand. When it becomes late, that's when the pain starts to rush. Understand? Maybe during the accident, right? During the accident, you might see that someone can be after that person hit by the car, the person can stand up and walk, and then jiggy after 2 minutes the person fall, and then now he start to scream. Right, that moment when we stand up and still going, we can talk about the adrenaline. We are still going to talk about it, and we are also going to talk about sympathetic response. It means that the person is responding to that accident sympathetically, right? The neurons and the what they're still sending the message to the brain. Yes, the person is affected, the receptors have collected the impulse, and the impulse is still being sent to the brain. Then when you reach the brain, that's when the pain is being interpreted. When you are at coma, when you are dying, my brother. So these are the symptoms. Yeah? You lose of speech and vision. You'll understand tomorrow. We're going to talk about next week. We're going to talk about the human eye, and then human eye also have the optic nerve, the nerve that takes whatever you are seeing to the brain, and the motor neurons, right? So this nerve, the nerve is made out of two neurons, right? Two neurons, right? Sensory neuron and the motor neuron. So this nerve here is called optic nerve. So this nerve here, if we are going to say the nerve, when now you can see, right? But the impulse here goes slow. It means that your vision now is going to be disturbed. You understand? Whatever you are seeing here, you are seeing it at HD. But if there is tara, it means that the message now is going in. Yes, we can see, because you can see well. It means that the message is going in, but the message is being sent there at a slower rate. We need you to function more here. We need you to function at 100% vision and what. So we will have the difficulty in walking, right? When now you will stand up, but it will be difficult for you to place another leg in front, because the message for that voluntary muscles is taking long to reach that place, right? You will also feel pain. This pain is all due to your receptors. They recepted the pain, and then it will take time for them to reach a central nervous system. By the time they reach the central nervous system, when now you are just feeling pain somewhere, right? Or maybe you had a cut somewhere, but you didn't hear the cut, but after that you're just feeling the pain. I got cut or something like this, right? And then you fatigue, always tired, because the message will be sent to your brain, and then the message will be sent from your brain to your nervous system for you to rest. But the message or the impulse will be received at it factor after a long time, right? So hence you are going to be fatigued. Fatigue kumlapo, tsamolapile. 40, 20 to 30. Hence they said you don't get tired while you are still at 20 and 40. right? You are still energetic. The time you get tired, we can now think, all right, something is happening. Maybe the fatigue. If it's not something to do with multiple sclerosis, now we can go and prove our hypothesis somewhere. Maybe their kidneys, they are not working. Maybe they are what do you call their lungs, then you understand. So this is the thing. And then you also have the memory loss, right? Because the memories that they are being sent, here's the thing, whatever you are seeing here, this is going to have a memory, right? This memory, let's talk about the memory. Whatever you are seeing here, this is going to be interpreted as a memory. It's going to be sent to the cerebellum, right? When it reads the cerebellum, it's going to be stored on our interneuron. Here's the thing. Tomorrow, when you see something like this, you will be remembered, oh, I once saw something like this, right? So here with the memory loss, this memory of what that we are talking about here, you are seeing it now, but it's going to take time for it to reach the central neuron. By the time it reaches the central neuron, you are now seeing something else. By the time this message is stored here in cerebrum, you are now seeing something else. So with that default, you end up losing something in between. Because you're concentrating on this while your body is still doing a memory of this. You are seeing this now while you understand something. Your leg, you are feeling pain. Your arms, what. By the time all those memories reach up the cerebrum, you have already know which one to concentrate in, right? So you also suffer from memory loss. So from there, our textbook said we should also deal with injuries, but this part here, they don't examine it. They don't ask you about this in examination, right? So we're just going to pass by this. But there are many causes of brain and spinal cord injuries, but the most common is a motor vehicle accident, right? The injuries that we can see, the most common is a motor vehicle accident. Hence, here we give you a road accident fund, my guy. Because we know that these motors of ours, yes, the government is saying this road of ours that we build, these motors of ours that we build, they caused you this damage. We have to go to compensate you, right? Because there's no way you are going to kill you. Just allow. You are wheelchair bound, maybe through God grace you are still going to walk again, but since you are a wheelchair bound, there's a possibility of you to be in this wheelchair bound for the wire, because we don't have cure for this, right? So but brain injuries can affect movement and memory and speech, but this depends on the part of the brain that is injured. In severe cases, they may lead to a long-term mental disease. If you are more seriously damaged, this can lead to a long-term mental health issue, right? You can forget everything. If you are in an accident, you might find those people who survive an accident, they came up not even knowing anything, right? I once saw this movie with Adam Sandler. The girl, she was involved in a car accident, and then after that, every day, I'm not sure what is the name of that movie. What's the name of that movie? Then every day, the family of that girl, they have to come and arrange the scene as like before, right? They prepared one day over and over again, because in that girl's mind, here's the thing, in that girl's mind, the message that is, they maybe like, let's do like this, right? The message was coming into the brain. Then that message is repeating itself. Today she's going to see this, and tomorrow she's still going to see this. So if she sees something, you go and search this movie. I'll go and look for this movie. I'll comment the name of the movie, right? The Adam Sandler movie, what, I'll go and I'll comment this, right? I'll comment this so that I'll be reminded to comment the movie here. They are dealing with brain damage due to accident. But a damaged spinal cord could result in paralysis and the inability to move or feel anything below the point of injury. I talked about this. If this is a spinal cord and then you get chopped here, your legs there, they can be affected, or they can be paralyzed, or inability to move or feel anything. You know what is happening now, you can explain it, right? So if someone goes in accident and they have the memory loss, we can say that the damage, it was in the brain. Right? Then if they get paralyzed, but they can think everything, they can remember everything, it means that the damage was on a spinal cord. You should be able to explain that, right? So, Barry, there is no way, the one that is the effect of drugs is the one that is not examinated. This injuries one, in information that if you are able to interpret these informations, you are well, you can now congratulate yourself. the week one, you are done with it, right? But there is no way of regenerating damaged nerve tissues. However, regular occupational and physical therapy may allow patients to regain some of feelings and function, right? When those nerves, they are damaged while you are going therapies, walking, some nerves can develop and start working again, right? But the medical researchers claim, this is what they're claiming, the medical researchers, they are claiming that the stem cell therapy may in future be used to repair spinal cord injuries, degenerative diseases such as multiple sclerosis and Parkinson diseases. This is another diseases, or the Alzheimer's here in our case, right? Our Alzheimer's disease. These are the Alzheimer's disease. These are diseases that are being called by Alzheimer. They are caused by a degeneration of our stem cells, right? Hence we say the Alzheimer's disease. So the drug part now, more by the marijuana, more those who are doing the drugs. But the drugs, here's the thing, okay, the drugs change the way in which impulses are transmitted in a central nervous system, right? The drugs, they are changing the way, they're just changing the way. They are not going to kill here's the thing, they're not going to kill anything. They're just going to cause some confusion in your brain. Hence when you are high or when you are doing drugs, you start to see things that are not there. It means that these drugs, they are changing the way in which the impulse are transmitted in a central nervous system, but mainly by affecting how quickly or how slow the neurotransmitter can pass across the gap called synapses, depending on the type of drug used. This can be marijuana, ecstasy, heroin, yak, tick, the Western Cape, mo heroin, mo Gauteng, mo. This one, what do you call? And Free State. This one we call it nyawupe, right? Heroin nyawupe. But either this can affect you, either sympathetic or parasympathetic nervous system will become more stimulated. This can lead to the side effects such as they will reduce your coordination, they will increase the heartbeat, right? They will increase your blood pressure, but they will decrease appetite and they will hallucinate and paranoid. Someone can say if you are smoking marijuana, this increases the appetite. So what is happening here? Here is your central nervous system, right? And then this is impulse coming in, there's the impulse coming out. This will be like this, right? So they're saying that this can affect your sympathetic and parasympathetic. You know that with sympathetic and parasympathetic, we are only focusing on the motor neuron, that they are going to affect our we're going to do like this, our heart here, right? So if you are going to be affected sympathetically, your heart is going to be increased, your heart rate is going to be increased. So if this weed or if this marijuana or if this tick, they are affecting you sympathetically, they are increasing the stimuli, right? They are increasing the way the synapses, those neurotransmitters that are being produced to another synapses, they are increasing the way these are produced or how these are being taken here. So increasing sympathetically, they're going to increase your rate. If it's going to reduce your coordination, hence you see someone say, hey, hello mang aribosho, it means that those it's not like they are sensory neurons and what they are affected. No, what is happening there at synapses, we learn about the synapses, right? We know what is happening there at the synapses. It's what is fun in this problem. Those synapses there, those drugs there or those heroin can cause the neurotransmitters here to be released or to be lowered. It means that this person is going to release 2 neurotransmitters or 3 neurotransmitters. When now you greet the person and the person heard that you greeted him, right? Then he's sending the impulse. Now he's sending from the cerebellum, he's sending the impulse to the legs, to the mouth, to the hand, to everything, so that he will respond to your hello, right? But the impulse there, you see that when we reach our synapses, our motor neurons, when they reach our synapses, they are releasing a few neurotransmitter. It means that our motor neuron, they are going to be affected, the affection or the rate of our activating of our motor neuron is going to be reduced, right? It means that the electrical impulse here is going to be shortened. When you attack that effector, now we are attacking that hand so that he will raise it. Now we are attacking that voice so that you can release it. The system is going to be slow and the person now is going to be saying boo. You get me? But the response is always there. And then when we come, okay, let's come to the increase of appetite here. Why marijuana, they increase appetite here? You know that appetite, we are dealing with a peristalsis, right? It means that Are you affected sympathetic or are you affected parasympathetic? We are going to say this marijuana, they are going to affect us parasympathetic. Why? Because the motor neuron, they are going to move out electrocuted, and then they reach our involuntary muscles. Those involuntary muscles here, we're talking about the bolus, the movement of bolus, peristalsis, right? So it's going to affect this peristalsis. This peristalsis is going to be increased. And where do we see the peristalsis being increased? We see it under parasympathetic. These bolus, they are going to be increased now. The food is going to move down while everything, the food is going to be digested and everything. Here we see it in parasympathetic. While this thing is happening, so that your body can fill up the food, hence you feel the edge of munchies. And they will talk about the munchies. After smoking those weed, people now they eat. It means that drug that you are using, it is affecting you parasympathetically, right? Or whatever. So it can decrease the appetite, it can increase the appetite. It can increase the heart rate, it can decrease the heart rate. It can increase blood pressure, or it can decrease blood pressure, depending on the type or the way that drug it is affecting you. This is not going to be examined. This is just a day by day knowledge that you'll have to know, since you know that our classes or our classmate, my guys, there's those people, they're smoking weed. You came to a class, or you come to attend a class, you find a class in Kali weed. So now you can sit down and explain them. Or when you see like this, maybe you have seen, you are here. Okay, let's say the person is hallucinating. Yeah, right? He's hearing things that are not there. It means that person, there we have a human ear, right? We are going to talk about the human ear next week. In human ear, the waves enters the ear via the canal, and then we also have the nerve that is going to take that impulses, or they are going to be recepted, converting that stimuli, which is the sound wave, to the impulse, and then that impulse is going to send to the cerebrum, right? Well, now when you hallucinate, these impulses of ours, or here at our receptors, it means that your receptors or your sensory neuron, the path or the impulse here, or when our receptors here converting whatever they are taking to the impulse, those neurons or those synaptic or what we call neurotransmitter that are being removed there, they are going to remove, or they're going to send the wrong impulse. When your ears had a murar, or you had nothing, or maybe no one is calling you, but when you can just hear people calling you, hello, how are you? Hello, very paranoia. This paranoia, and the son in the song, I will say people, they don't really know. Do you understand? Hallucinating, you are hearing things, or you are seeing things that you are going to talk about the human eye tomorrow, next week. You are seeing things that are not there. It means those receptors inside your eye, they are picking up something that is not there. Or they are converting something is not there into the impulse, and that impulse, when it reaches your cerebrum, where now you are seeing things. Muna, wow, why do you look like you are laughing? Muna, your face is moving upside and down. Hey, you understand? So thank you. Let me not waste your time. Today it's Friday. Done, guys. We are done, guys. I promised you an activity, right? I promised you an activity 2023. Let's come and do the activity. We are done, guys. Friday. Let's meet Monday. This is us, right? Basic education, grade 12, last year, 2023. They asked this question here, Aljema. Or let me show you where we found those 14 marks, right? You know how to scan our question paper. You know how to draw line graph. You know how to draw histogram. And then those tables and what you know those. You have to write the table. You have to give like, but draw the histogram. You write the heading. You draw that histogram, something like this, right? You label your x-axis, your y-axis. Then here's the question, and then we did this yesterday, or we did this previously on African transcribers, right? So question 3, thank you for being here, thank you for holding on, right? Today's Friday, malamulele. Thank you, guys. Today, here's the question, Alzheimer's disease and the exercise. Well, now you have to come here with the basic knowledge of what is happening with Alzheimer's. Now you know what is happening with Alzheimer's. And the exercise, right? This is the extract. So you can see marks there, 14. So out of 54 minus 14, do the calculation, right? When I do the calculation, you might think like, Mr. Mpepu, he's wasting his time. Think twice, right? So let's come and do this with our knowledge of our Alzheimer's, right? So here's the thing. But age and family, right? Let's read this together. After reading this, I'll show you how we analyze this. I'm not going to write anything so that we'll read everything. You can read it, you can pause, read it yourself, skip. The time I come and do this, you'll see that we are done. Age and family history are age and family history are the known risk factors for Alzheimer's diseases. The most common symptoms of Alzheimer's disease is a worsening ability to remember new information. Regular exercise may help to reduce the risk of developing Alzheimer's diseases because it can improve blood flow to the brain and help to maintain the volume of the hippocampus. A hippocampus is located deep inside the cerebrum and plays a major role in learning ability and orientation. Scientists conducted an investigation to determine if regular exercises reduces the risk of Alzheimer's diseases in humans. They used 37 female participants between the age of 65 and 75 in an exercise program. Used participants that they did not show symptoms of Alzheimer's diseases at the start of the investigation. Conducted the investigation 3 times a week for 3 months. The results showed an improvement in high order thinking abilities and an increased blood flow to the cerebellum. Right, this is the story we read, so we can go back now. See, okay, now let's decode the question. First thing, let's decode the question. We take it down to the simplest form. Here we are finding that we have the age and a family history, that there are known risk or the unknown factors of Alzheimer's, right? So from there, but the most common symptoms, the most common symptoms that we see of an Alzheimer's is the worsening ability to remember new information. This is the symptoms, right? But okay, it's fine. We are done with the first paragraph. Second paragraph, but a regular exercise may, right? May, no, the print or what, learn this in English. May not, will not, shall not, right? A regular exercise may help to reduce, it means that there's a possibility of this exercise, regular exercises may help to reduce the risk of developing Alzheimer's disease, right? Because why? Because these exercises, it can help blood flow to the brain, right? Because it can improve blood flow to the brain, and it can help to maintain the volume of hippocampus. What is hippocampus? We at this moment we didn't even know what is hippocampus, or we didn't even know that our brain they have hippocampus. Since this one it improves the blood flow to the brain, and then it helps to maintain the volume of hippocampus. Now we know that in our brain we have a structure called hippocampus, right? This structure, hippocampus, the other name of this is a seahorse, because it is situated inside our brain, and it looks like, if you know the seahorse, go and Google this structure if you want to learn more about it, right? But then they told us now, agree this, they know this hippocampus, we don't know hippocampus, we don't know anything about it. They gave us another information, but the hippocampus, so if they give you another new name, other than cerebrum, cerebellum, medulla oblongata, what, maybe they give you thallus. We also have something called thallus, right, if I'm not mistaken. And then we also have hypothalamus, right? We have thallus. Is this thalamus or thalamus? But something with thallus, right? They can also give you this thallus, and then they'll give you an explanation at the top, because in our syllabus or in our plan or in our examination, what these parts of the brain are not there. The brain is made out of many parts. So get that. But the hippocampus is located deep. This way now, where is this located? Hippocampus, it's located deep inside the cerebrum, right? Where we do with thinking and what. And it plays a major role in learning ability and orientation. This is the function that they are telling us. So this one, it plays a role in learning ability and orientation. Then we go down, another one, they said, okay, the scientists conducted an investigation to determine if regular exercise reduces the risk of Alzheimer's. They conducted an investigation, right? To do what? What was the aim? To determine if regular exercises reduces the risk of Alzheimer's. They are determining if. This is how you have to decode this question. They are determining if. They can say if or if not. The answer here can say yes, it can, or no, it cannot, because they are determining if Regular exercises reduces the risk of Alzheimer's disease in human, right? So it means that if you have Alzheimer's and you are going to exercise, your Alzheimer's is going to be decreased, right? Or if you don't have Alzheimer's, you go and exercise, you are not going to suffer from that Alzheimer's. They are just trying to find that out. And then this is what they did, right? They did these three things. But the scientists, right? They used 37 females participants between the age of 65 and 75. We know that our Alzheimer now start at 60. So they started at the 65 and 75, same age group, right? But in an exercise program, they took this to the exercise. You know, we had a program somewhere back there, 2020, 2022, where our grandmothers, they were going to the ground yard playing soccer. So we used to be shown matches between our grandparents playing soccer, but now it's not there. I'm not sure what happened. Go and Google them, you'll see those oldies, grannies playing those soccers, right? So these were the scientists trying to find if the regular exercise reduces, right? And then from there, but they used another point. They used participants that did not show the Alzheimer's diseases at the start of the investigation. So we start with those that they are not showing the Alzheimer's diseases, and then after this we are going to see if that person is going to have Alzheimer's diseases. So we can come with hypothesis here. If you don't have a Alzheimer's, you exercise, and then after 3 months, here they say they conducted the investigation 3 times a week, and for 3 months. After 3 months, you don't have Alzheimer's. We can now think maybe the exercises can reduce, right? So this is what they are saying, right? They used participants that did not show symptoms Alzheimer's at the start of the investigation. They started with those that they don't have Alzheimer's, and then they conducted the investigation 3 times a week. So we can say Monday, Wednesday, and Friday. They were exercising Monday, Wednesday, Friday for 3 months, right? So this is what is happening with this. Can you explain this to someone? Yes. Can you break this down to an understandable manner? Yes. And then, but the results showed an improvement. The results, right, showed an improvement in a higher order thinking ability. It means that our higher order they increase their higher order ability, right? We can say this well because here in this paragraph 2, the regular exercises, they told us that it increases, it maintain the volume of hypothalamus, and this hippocampus play a major role in learning and orientation. So after these people exercising, for sure, we were expecting to increase our thinking ability and an increased blood flow to the cerebrum, right? This is what the exercise do to your body. It increase. These are the results that we see, but also these are the results of thinking. You know, these are the results of exercising. You know, some people before they go and study, they start now by exercising, right? While you are exercising, you are increasing your thinking ability, and also you are increasing the blood flow to the brain, so that the hippocampus there, it can be maintained, or the volume there can be increased, right? With that, you are increasing the ability to learn, and then you are also increasing the ability to think, and you are also increasing the blood flow to the cerebrum, right? We learn many things from this extract, so we can now go and answer the questions. But question 3.1.1 asks, question 3.1.1 is state one change, okay, here. But state one change in the nerve tissue of the brain that can cause Alzheimer's diseases. Oh, my back. Okay. They want us to state one change in a nerve tissue, right? They want us to state one change in a nerve tissue of the brain that can cause Alzheimer's. Here they only want you to come up with what causes Alzheimer's. You can see they are not saying from the extract, right? Some questions from the extract. Here they just tell us, state one change. State it. Say it. What is it that one change if it happens to our brain where now there's a possibility of you to suffer from Alzheimer's? You can come and say a nerve cell death, right? Nerve cells, or dying of nerve cells, right? Dying of nerve cell death, right? And then we could also say the degeneration, if you want to use a specified English or spiced English, degeneration of a nerve tissue. What is causing this, you don't know, but you can know Are they dying? Maybe you don't know. But what you know is that their nerve tissue, they are degenerating. They are losing the number. Or you can also say the plaque I told about, talk about this, or the proteins developing. I can remember one change. So if proteins developing between, or developing between, yes, between neurons or nerves, right, between nerve cells, right? So you are stating one change in the nerve tissue inside the brain that can cause Alzheimer. You know, nerve tissue is made out of neurons, right? So when these proteins, they are growing around these neurons, they are going to squish and they can cause Alzheimer. Or if these neurons of ours, they are just dying, Alzheimer can be caused, right? 1 mark either way. And then 3.1.2 from the extract. From the extract, let's do like this. Allow me to do like this. But tabang, my good people, askis, ish, sure. Then we are here, right? Can't tell, we are here, right? We are 20. Excuse. I'm sorry. 2023, right? So we are at 3.1.2. Let's do this. Okay, we are at 3.1.2, but from the extract, right? Let me decrease this. Thank you for being here, guys. I appreciate you. You know that I appreciate you. 3.1.2 from the extract state, number 8. They want answer what A. But from the extract, right? From the extract, we have to come here to this extract and have answer that will come and answer these three what, right? From the extract, right? But from the extract, state one symptom of Alzheimer diseases, right? Or Alzheimer disease. One symptoms. We go to our first, we know that this diseases is a worsening. So this will be the symptoms. When we see a worsening ability to remember new information, that now we can say that one is the symptoms of Alzheimer, right? From the extract, right? But this is an extract, or this is okay, yeah, they say, let me refresh this, right? Let me just refresh this so that I don't miss other information. I don't miss some information because I'm starting to miss them even. Yes, they say the common symptoms of Alzheimer is. So here they want the symptoms. You are just going to copy this. Do we have to write them this side? No, I don't have to write it. Worsening ability from here. A worsening ability to remember new information would be the answer for this, right? You can see you're just copying it from the extract. Number B, number B from the extract state a genetic risk factor. A genetic risk factor. We talked about the risk here, but the age and a family history are the known risk factors of Alzheimer. Here they want, here's the thing. This one, I click on mahal. Yes, we know that we talked about the age, and here they said from the extract state a genetic risk factor. They want one. Here we talked about the age and a family history. Age, will the age be a genetic factor? No. Family history, yes, because in a family history we can link this in genetically what, or if your forefather, or if papa how suffered Alzheimer, and then your father suffered Alzheimer, and then even you are suffering Alzheimer, we can now say this is a genetic disorder. So we want it here. We want this genetic. The key word here is a genetic risk. Age is not genetic. Here you are going to say family history, right? Family history. Number C, you see now, you have to master this. I told you yesterday that for you to play at 75% of distinction, you have to master these extract questions and the investigation questions, because here they know for you to use your mind, for you to use your cerebrum, you have to use your cerebrum here. Okay, from the extract again, go to the extract and come up or state the two functions of hippocampus. This one is free. Just go to the extract and come up with two functions of hippocampus. They told us, right? But hey, somewhere here, the hippocampus is located deep inside the cerebrum, and it plays a major role in learning ability and orientation. You just come here and say learning ability and orientation. You get these two. These are the functions that we get of the hippocampus. So you see, they are not going to come up with new structures or new position inside the brain and just come here and say, where enough from you give us two functions of that brain. We didn't. You can tell them that it was not on our syllabus. We didn't learn about this. Then also determine, because you know that, you see, here's the thing. Here's another thing. Another the tip of the day. Tip of the day. When now you come to 3.1.1, this is the tip of the day, right? And you leave the blank space, right? Maybe they are asking you state 1 changes in the nerve tissue of the brain, and that can cause some diseases here that we didn't learn about it, right? It was, and then the cause is not stated here in this extract. When now you leave the blank page, and then someone come and say 3.1.1 and said, or maybe I don't know, right? Or I can't remember. He answered something, right? Did you know that if after writing, and then the chief mark, I'm still going to tell you, I'm still going to outline to you what happened before and after, what happened in the process of marking your question papers and everything, right? The marking session and everything, how they treat your question paper, how they treat these questions, how they treat them, the memorandum, how your paper get marked from the first person opening your final answer sheet to the last person writing down that way. Now you scored 75%. The whole system here, from you writing at your school up until this marks here, I'm still going to explain this to you one day along the way, right? So I was here. You come here, and then the marker or the chief marker and the person who's responsible for this paper, they come and say, they argue that this question here, it was wrong. Right, they argued this question here, it was wrong, or the question here was not moderated, or the question here, there's something wrong that learners cannot give the answer here, right? Maybe someone come and answer something, now you leave the blank, and then they decide to just go and give one answer for any answer that person placed there. If that person answered, just go and give them that one. When they come to your page, when they come to your answer book and they found a blank space, do you think there's someone who will just come and give you that one mark there at the blank space? No, right? So you'll have to answer something. Even if you don't know it, even if you are not sure, just come and answer. But state 1 damage in the nerve cell of the brain that cause a Alzheimer what. Come and write as cell dying or cell reducing in number. Cell what. If they see, or this question here was maybe the cognitive level, the toughness or the easiness of this question was maybe higher, maybe this question can be only understood by someone from university or someone who's doing PhD. They are now saying, let's go and give our learners one mark. They come here, they find you with a blank space. There's no way they're going to give you that 1 mark. Right? For them to give you that 1 mark, they have to come and see the answer. And if that answer is there, we are just giving that mark and we leave it like that. You answered. You tried. So here's that was the tip of the day, right? So we move on. I hope you get that. Thank you for being here, guys. Then 2, we were answering 2.1.2, right? But 2 function of hippocampus, United Side learning ability and orientation, right? We are getting them from the extract here. You are not saying this hippocampus, they can say, hey, it is used to think, it is used to store memory, it is used to do what. That is the information outside the extract. Even if when they ask you a question, state the function of cerebrum. There's a function, many function of cerebrum, but they also, you'll understand that they need those who you learned from grade 12 teachers, or those who learn from grade 12 syllabus, right? The memory storage, the control of voluntary muscles. Do you understand? So let's move on. Let's finish this. Today's Friday. Thank you for being here. I appreciate you guys. I will always appreciate you. So okay, 3.3.3. Name 2 factors that were considered when selecting the participation for this investigation. When we learn the investigation, we have questions that are dealing with investigation, dependent, independent. What is it that they do for reliability, for this investigation to be reliable? What are the control factors? What were we understand? Those are the questions that they come with investigation. Same as this one. But name 2 factors. We want 2 factors that they were considered when selecting the participant. We can get them here, right? We only want 2. Let's go to our extract and see 2 factors that they were considered. What is it that they consider to say when we are selecting these people, right, here we can see that they selected 37 participants. When we were selecting these 37 participants, what is it that we were considering? We only want 2, right? You can say they considered that they have to be females, right? Because they only have females, right? And then one, the female there, another one, same age group. It was not only female, right? Oh, same age group, around 67 and 65, right? And then another thing that they consider, maybe another thing, there's only say 2, right? Another thing that they consider here when they selecting these people here, they also consider that these people, they should not show the symptoms of angina. So if you were showing the symptoms of angina, you were out of the group. If you were not a female, you were out of the group. If you were not at the age between 55 and 75, you were also out of the group, right? Those are the 2 factors. I named 3. And then 3.1.4, there's more answers they can come from the extract, but if they say they want 2, give them 2, right? Although you can find that you can name 3 and then they also come and answer these 2 and then maybe make a line here and cancel this. Then here's the problem of giving them this information here. You can answer 1, answer 2, answer 3, and we find that the first one is correct, the second one is wrong, the third one it was correct, but because now you answered 3 like this, we are going to take the first one, the second one, this one is going to be crossed out. So name 2, give your best 2, right? When you come here, you choose your best 2, the female and the age group, and then this one you choose your best 2 and then you move on, right? Then 1.1.5, explain why this investigation cannot be used to conclude that exercise reduces the risk of getting Alzheimer's diseases. There are 2 marks, right? Here only one explanation. You give them one explanation that you can explain here, they are going to give you this 2 mark because they're saying explain why, right? Give us your explanation why this investigation of ours are up here, right? Explain why this investigation of ours cannot be used as a conclusion. We cannot come and say this exercises reduces the risk of getting Alzheimer, right? So and now explain to us. Explain to us why we cannot come and say exercises reduce the getting Alzheimer, right? That's the question. The question needs you to explain why you cannot conclude, why you cannot say exercise reduce the risk of getting Alzheimer. Let's go to our extract and see those questions, right? One thing we can say, right, we can say that this experiment or this so you to use your mind, right, of your knowledge of the investigation, how the investigation has to work, right? If you see this, if this and this and this are not there in this investigation, the conclusion cannot be that much, right? So let's do this and let's see, right? This investigation here, we cannot conclude. Why? Because you can come and say we have 37 females, right? Here's the thing, we have 37 females and then there's 37 females and then out of these 37 females we came and, okay, another thing, okay, it's fine, with 37 females we came and exercises them and then this one they have to have no symptoms, right? All of them, they have no symptoms, right? We exercise them, then after exercising them, that was it, right? So why we cannot conclude that after exercising, this exercise was there, was the main reason why these females here, they don't have angina. The first thing we can say, because the people that they were chosen, they didn't have the symptoms, right? How are we going to conclude that exercise reduces the risk of angina if the people didn't have any symptoms? We don't know whether these 35 individuals, they were going to suffer for angina or they were not going to suffer for angina. We just went and took 37, right? When you are explaining, you explain in your, now I'm just explaining to you the possible answers that we can come out to answer this question of ours, right? Because we didn't know, or how are we going to measure? Maybe we didn't measure their brain size, right, or their angina. You know that in an angina we are going to see our brain size decreasing, right? So, and another thing, this angina, we will say that maybe you were a baby here, you were born, and then you were born with 50 neurons, and then at the age of 18 you had 180 neurons, and then at the age of 60 we see now that you have maybe, like, let's take 40 neurons, right? So you can see from 18, maybe they were increasing up until the age 18, and then from 18 up until 60 they start to degenerate, right? So at the age of 60 here, you can see this process here takes a long time. And there's no way that you are going to prove that exercise is going to reduce these symptoms here by only exercising people 3 months. It took 18 years, from 18 years up until 60 years. It took many years. It takes many years to develop, to be diagnosed with Alzheimer. And then when now you cannot just come and exercise 3 months and then we can now conclude. There's the thing. They're saying why you cannot conclude. Hana, deny this fact your Alzheimer can decrease the exercises can decrease the development of Alzheimer. Disagree with this. Tell them. Then another thing, we didn't have control, right? We didn't have control. If, for an example, if you know in our experiment, we have to have control, right? In this 37, we can come in this 37 female that they had no symptoms, right? We should be maybe took 18 this side and 18. I'm not sure if the total will make 37, right? We should take 18 this side, 18 this side, and exercise this 18 and leave this 18, right? So after the experiment, when this 18 are when this 18 year they are done with exercising, we come and check the symptoms of Alzheimer. And then in this 18 year they were not exercising, we come and check the Alzheimer. If in this side we find that maybe 15 out of 18 they suffered from Alzheimer, but this side maybe 1 out of 18 only suffered from Alzheimer, that's when we were going to conclude, or maybe, and you know, a conclusion that comes with maybe, it is still an hypothesis. It is still what you are thinking. It's not concluded. A conclusion, you have to come down and say exercises. I'm 100% sure that exercises reduces the development of Alzheimer. So now I'm saying no because we don't have controls there. Then how are we going to come up with a conclusion here? Exercise reduce the Alzheimer? Where? Do you understand? Because here they say the results that they obtain is just the higher order thinking ability and an increased blood flow. And then Alzheimer is caused by deteriorating or degenerating of those. So we're not increasing your thinking ability and increasing the blood flow doesn't mean that we are preventing Alzheimer. We are preventing the degeneration of these cells. They are not dying. They are still dying. It's just that you improved your thinking ability and the flow of blood to the cerebrum. But those cells, they are still dying. I hope you'll understand, or you'll get an understanding of how to answer this question here, right? How can you can you answer those exercises here, right? There's many answers to answer this question here of explain why this investigation cannot be used to conclude that exercises reduce the risk of getting Alzheimer diseases, right? When I can start by saying Alzheimer diseases is caused by Alzheimer diseases is caused by a degeneration of a cell, right? And then after exercising, we found that these exercises only increase the ability, the thinking ability, and the flow of cerebellum. In total, or therefore, these results here, they are not increasing, or they are not reducing the development or the deteriorating of this Alzheimer. With that being said, we cannot conclude that our exercises, they are reducing the risk of Alzheimer. 2 marks. Any explanation that you'll come with, it's going to worth this 2 marks if you are heading to the right direction, right? Whether you are heading to the right direction, we are going to give you 2 marks. So the last one, we are done, 3.1.6. And then from the extract, now we have to run back to the extract now. This one was only for your explanation and your imagination and using of your cerebrum. You are using your cerebrum here to answer this. And then 1.1.6, you are just going to take the answer from the extract. But from the extract, try to explain to us why it is expected that regular exercise can reduce the risk of Alzheimer. Right, from the extract, go to the extract and try to explain to us or why it is or why it was expected that if we take this group of people, if we take this 70 group of people and exercises them, this can reduce the risk of Alzheimer. Go to the extract and come up with those explanations. Or why? You understand? This is how we decode the question. They say 3 marks. This is how you decode. After decoding a question, that's when you can now see, now I understand what they want. They want me to go to the extract and pick up or come up or try to search three worth answer, 3 worth mark answer here, trying to explain why it is expected. or why it was, because this was already done, right? Why it was expected that regular exercise, this exercising is going to reduce the risk of Alzheimer. So let's go to the extract. And then they said here, regular exercise may, right, that's what they were thinking, may help to reduce the risk of development of diseases because it, explain because. Here, you see, they said explain why it was expected. It was expected because it can improve blood flow to the brain. You get your one? And it will help to maintain the volume of hippocampus. You get your two? Another one, where are you going to get this? This is going to increase your learning and orientation. You get your three. So you see, when they say from the extract, go to the extract and find the answer. Don't bring up your thing, right? Why they thought the exercise is going to reduce this Alzheimer? Because these exercises, we see that it can improve the blood flow to the brain, right? While the blood flow is improving to the brain, this will help to maintain the volume of hippocampus, right? Then hippocampus is located, this information here, you're going to skip it. The hippocampus is located deep inside the cerebrum, right? You're going to skip it and then place the major role in learning, and then you are going to say, and this will improve our learning ability and orientation. Why are you saying this? Because these are the things that are going to be affected when we say when you have Alzheimer. Because you will have Alzheimer, your learning ability is going to decrease, your memory loss, you get confused, right? And then orientation, orientation, life orientation, we are putting you on your line, right? We are orientating you, Rebecca, the way that you can be, the how the body can work properly, right? Orientation, body orientation. When you are saying that your body is working properly, you are saying that your body is orientated. So thank you. My name is Mr. Mpepu. Until we meet again, we are going to meet on Monday doing the human eye. Then we are done here. You can see where this 14 marks is coming from, right? Don't be scared when you come to these questions. Relax and read the extract. After reading the extract, understand. While you are reading it, understand it. Or you can start by reading all of it. After reading all of it, now you come back and try to fill up those information that you learned from the extract, right? So thank you for being here, guys. I will say thank you. I see you on Monday, guys. Thank you. Don't forget to subscribe. Those who are subscribing, don't forget to comment. Don't forget to like. Until we meet again, guys. What can I say? Nothing. Now, just like to appreciate those who are subscribing, guys. You are making me a human being, right? So, thank you, guys. Thank you. Until we meet again Monday. Tomorrow, I'm not going to post any video, so that will give time for those who are catching up to catch up. Then Monday, we use this information, peripheral, what we do. A human eye. Human eye is a receptor organ. A human eye is a receptor organ. When we say it's a receptor organ, it's an organ that it is made, or it consists of many receptor cells. Like a human eye, we have the receptor cells. Like your nose, olfactory, we have the receptors. Like your tongue, this one, we say your tongue, it's your sense organ, right? This your tongue, it's your sense organ. It has many receptors that they are going to test sour, they are going to test what when after that receptor send it into the impulse, and then impulse via the cranial nerve to the central nervous system. You understand that, right? So from there, there's cranium, cerebrum, hence, and then inside the cerebrum, the message is going to be interpreted, and then your cerebrum is going to tell you, where now you are cerebrum. Where's you? You are inside. Where is I? Is this thing I? My name is, or I am feeling pain. I am whatever. I am down. Right? That I that you are talking about your central nervous system, your cerebrum. Where you are thinking, whatever you are seeing. When we said the moment we say the person is dead, it means the central nervous system is dead. That's the only way we can say the person is dead. Why? Because when you can be dead and then your heart still pumping. You can be dead and then your kidney still functioning. You can be dead, your lungs are still functioning. You can be dead and what else, whatever in your body might be still functioning, but we can say this person died, and hence we can take your heart and transfer it to someone else. Or did you know that the first heart transplant was done here in South Africa? Did you know that? And then from there, what another thing, the brain, we have never come across they have never successfully transplanted a human brain. Did you know that? A human brain, when you talk about the human brain, that is the complicated thing. And never there was a successful story where we said we remove a human brain from one person and transplant it, or we place it into someone else. We can do with kidneys, we can do with stomach, we can do with liver, we can do with heart, we can do with lungs, we can do with tongue, we can do with everything. But when it comes to heart, when it comes to the brain, that's the last part, right? So I was saying that what another thing that I was saying, that I was trying to say. Good, okay, another thing here, these are the sensory organs, right? They sense this and then they send it to the, and then another thing, those who are from here, from my YouTube, right? We can push this. I'm not sure what the time is because today I don't have the timer. Sorry, as kiss. And then those who are from WhatsApp, now it's our time. Those who are not here from WhatsApp, those who are here for class, they can now exit, right? Thank you for being here. We welcome you. Thank you. You can now stop the video and go and do your things. But those who are from WhatsApp, we said that we are going to talk about which one is better between the AI and a human brain, or a human nervous system. An AI, you know that we have a chip. We call it a chip inside the head there, and then that chip is computerized, and then that computerized, maybe whatever that robot is seeing, it has to be interpreted at the computer there, the chip. And then whatever that if that chip is saying that that robot has to lift up their arm, whatever it's happening, whatever that robot is doing is being done by the chip. And whatever our body is doing is being controlled there at our central nervous system. So which one is best here between these two, between an AI and human brain? We can take this to a very, very much complicated thing. When I can come now, I can ask you, from what basis are you asking this question? From the complexity of things. Human beings, they think things outside of the box, right? The AI, they just do things, right? That's another thing that we can bring. But what is happening, that is none of our business. We are here for life science. Next week we'll be doing the human eye, what is happening inside the human eye. I told you that a human eye is the most complicated organ, right, after a tissue. In human eye, we also have the nerve, and then whatever you are seeing here is passed to the nerve and then to the cranium, to the cerebrum, right? Even with your eye, even if with your nose, you know olfactory, even with your mouth, you know the tongue, right? The tongue is the nerve that is taking whatever you are tasting to the brain. So with that being said, guys, thank you for being here. See you Monday, right? See you Monday. We are done with our first week topic. We are done with this one here. We're done with our this week topic. Next week we are going to do a human eye. So guys, thank you for being here. Don't want to leave now. And I cannot prolong these videos, because someone, the moment they see that the videos are prolonged, they cannot plan their week to say, hey, the person want me to spend 2 hours under their videos. It means that I will have to compromise other things. So let's keep this short and simple, right? Thank you for being here, guys. Thank you. So those who are subscribing, subscribe bang, guys. Those who are commenting, comment what you have learned through this week, or what you are taking from these lessons from Monday up until Friday. What is it that you learned? What is it that maybe you didn't know that you learned from my classes? Guys, let's move on. Now we know that you touch something is hot. Guys, life science is beautiful, guys. It's life science is beautiful. Life science. From here, you can go out and be the doctor. You know, now we are dealing with the brain. You can go out and be the psychiatric. You can now be an opti, the person who are dealing with a human eye. They have those people who are dealing with a human ear. Same thing. The basics are this. Those who are dealing with the nerves, neurology, the study of nerves. These are the basics. They know these are the basics. We have the motor neuron, we have the sensory neuron, we have the what, right? A human nervous system, we have the brain. Now we go and learn the more details of the brain. There are those who are just concentrating on a human brain. Same as the dentist, they are only concentrating on your human teeth, right? So you can concentrate on, you can study everything in this. You can concentrate only on a spinal cord, you can concentrate only on a kidney. We did kidney grade 11. You can concentrate only on a stomach, being a doctor, a specialist, right? So thank you, thank you, thank you, Reina, as having this basic education. This basic education, that's the only thing that we can use to come and share with you. But we cannot be doctors. You know, we're doing genetic engineering. I was talking about building this thing where we can come and store your cells and then place them somewhere, and then your stem cells from placenta. We can just talk about those. So thank you for being here. Let me not waste your time, guys. Thank you. Until we meet again, we'll meet on Monday. My name is Mr. Pepo. Mwah, mwah, mwah. Peace, peace, peace. Shosholoza, guys, from Cape to Cairo. Even if it's hard, even if they are laughing to you, even if they're thinking you weren't going to be successful, shosholoza. This is me from me, and then this, let this be a, what we call, let this be a motivation to you also. Or there's a guy somewhere, he's just doing this, he's socializing, he's trying by all means to help or to bring out his skills to the world. So thank you, guys. Thank you. Friday, we're going to meet Monday. Sharp, sharp. Danko.